So to finish off, we're going to do part D this morning. First thing, when there is a variable under the radical, you need to state restrictions. This becomes very important when you are solving, right, which is going to happen on Thursday. So when you are solving radical equations, you have to be what value, what possible values can I put under there? So what's the restriction on x here? What's the restriction on x? So all of these are positive, right? 12x, 75x, 3x. We need them all to be greater than or equal to 0. And the way that's going to happen is if x is greater than or equal to 0. Okay? If x were negative, then each of these expressions would become negative, and we can't do the square root of a negative, right? So restrictions on square roots are that the term underneath the radical sign must be positive. Okay? If it's a cube root, doesn't matter. It could be negative, it could be positive. Okay, but on square roots, got to be positive. All right, then what we need to do is turn these into like radicals. Okay, we know that root 12 can be written as the root of 4, so we want a perfect square, right? So I can do these in detail. So 4 times, now 4 has a square root, and 3x doesn't. Minus 2 root. What's perfect square that goes into 75? 25. How many times? 3. So it's 25 times 3x minus root 3x. Right? Nothing to do with root 3x. It just is what it is. It doesn't simplify. So this becomes root 4 root 3x minus 2 root 25 root 3x minus root 3x, which is 2 root 3x minus 2 times 5 root 3x minus root 3x. So I'm just showing all. You wouldn't necessarily have to show all of these steps, right? If you can take 12 down to 2 root 3x, then we're good. So we got 2 root 3x. Let's string some equal signs in here because each line is equivalent to the line above, right? That's what equal sign says. When you've got something going down like this, you can go down, you can go back up again. Right? I can go from 2 root 3x to root 4 root 3x. Say these two guys are the same. Take this expression, write it like this. Say this expression is the same as that expression. Okay, minus 10 root 3x minus root 3x. So how many root 3x's do we have? They're just things, you know. I got two things, and I'm subtracting 10 things, and then I'm subtracting another one thing. How many things do I have? Wow, 4 days off, and the brain turns to mush. Negative 9 root 3x. Oh my god. Okay, I forget what I said about it. Yeah. Okay, so I have 2 apples, right? And I subtract 10 apples, that gives me negative 8 apples. And then I subtract 1 more, so I have negative 9. Of course, they're not apples, right? They're root 3x's. And that's why we had to change from an entire radical to a mixed radical to get to the point where we could collect like terms. And like terms have to have not only the root 3, it can't just be a root 3, it's got to be a root 3x. Right? If I had a root 3 in here plus root 3, that would just be plus root 3 on the bottom, right? It's not a like term. So like terms are exactly alike. Now, what could you do? I'd say you could go from like this line down to this line, or maybe even this line. So you go from here to here to here, right? It only takes a couple of lines. Stuff just goes right through you. Okay. What's the restriction on y? What can't y be?
X.
There's no x. Just deal with the y's. Why not?
Because you square a negative, people turn positive.
Okay. Cool. then I can take the root. So if we take a negative and raise it to an even power, it'll become positive, and we get 16 times the positive, which is positive, and we can take the root. So there is no restriction, right? Y belongs to the reals. Okay, so no restriction on the y. Because it's a square root and you're raising y to an even power, which is going to make the y positive, or the expression positive. Okay, what's the square root of 16y to the 10th? 16 have a square root? What is it? Does y to the 10th have a square root? What is it? Y to the 5th, right? What are we doing? We take half the power, right? Because y to the 5th times y to the 5th, right? Y to the 5th times y to the 5th is y. We add the exponents. Okay. So when you are taking the square root of an even power, you just cut power in half. So what does this give us here? What's the square root of y to the 12th? Y to the 6th. Okay, it's below the equal sign. What's negative 5y times 4y to the 5th? God, pulling teeth. Fine, I'm just doing it, man. I want to finish my apple. Negative 20y to the 6th plus 2y to the 6th, which is, and I'm just going to pause this for the 5. All right, so negative 18y to the 6th. Again, they're like terms, right? They're both y to the 6's. If we had a y to the 6th and a y to the 4th, then they're not like terms, right? It's part of what they are. What's the square root of w to the 5th? So how do we do this? Do you remember? So we can't take half of 5, so what do we have to do? We have to split it into an even power, and then a power of 1, right? The even power will have a square root. Okay, so we do that there. What do we do with the w to the 9th? How do I write w to the 9th? W to the 8 times w, right? So there's always just going to be a w to the 1, okay, if it's an odd power. So then we split the root. So that we write it as the square root of w to the 8th times the square root of w, and the square root of w to the 4th times the square root of w. So what we want under that first radical is something that has a square root. Right? So here, this had a square root, so we were good. We could just take the square root. Okay, so what do we get? Negative 4. What's the square root of w to the 4th? That's it. Just got to approach the apple. So we got w squared, and then we have a root w, right? What's the square root of w to the 6th? Or sorry, 8th. That's an 8.
4.
W to the 4th, root w. So what do we do with the negative 4 and the positive 5? What? Add. We can add like terms. Are they like terms?
Yeah.
Right. So I see a w squared root w, and I see a w to the 4th root w. Are those the same? No. So what do we do? Leave it. We're done. Right? That's it. That's the answer. Yep.
Why are you adding? Isn't it multiply?
Oh, you're right. Why am I at? All right, those of you who said multiply, you're right. So if it was add, then we would just leave it, right? Because we can't add like terms, right? Those two are add, or add, subtract. Okay, so now what do we do? Now we multiply, right? What do we get? Negative 20, w to the 6. What's the square root of w times the square root of w? Just w, right? So what's our final answer? W to the 7. Okay, good. Thank you for that. It could have been disastrous. Could have had that out there on the internet. All right. Is there anything else below here? Nope. Okay, ready to move on? Need a second to finish coffee? A quick polling of the class. See if we can move. Okay, so in this one, we have to apply the distributive law. So we've got 2 root p times 3 root p cubed. What's that going to give me? Start with the first part. What's 2 times 3? So we get 6. Root p to the power of 4. Okay, so we got root p times root p cubed. We put them together under a single radical sign where it becomes p cubed times p, which is p to the 4th. What's that equal to? 6. The square root of p to the 4th. P squared. Minus, okay, 2 times 6 is 12. What's under the radical sign? P to the 8th. What's the square root of p to the 8th? P4. Okay, this time it really is an add or subtract. Are they like terms? No. No. So what do? We leave it. You're done. Yeah, good. Remember that on Monday. What's 15 divided by negative 5? Let's go with negative 3, right? Positive divided by negative 15 divided by negative 5 is negative 3. What's the root of w to the 7th divided by the root of w cubed? What's the power? So we're dividing, what do we do with exponents? Subtract. What's that give us? What's the square root of w to the 4th?
2.
Okay. That's the exponent. I'd rather you said something like w squared, right? Square root of w to the 4th is w squared, not just what the exponent is, but what the actual. So, in F, we have a couple ways we can approach this. We can divide each term by root 2x, or sorry, 2 root x. Or we can kind of simplify things. The root 20 is 2 root 5x. So probably we should do that, because really I can't do this divided by this very easily. So let's simplify. Before we do any division, let's simplify. So root 20 is 2 root 5x. Okay, this time I'm not showing the work, I'm just doing it, right? That's your answer. So if you want, you can show more steps. Does everybody know how I got root 20 to be 2 root 5x?
4 root and then 5 root and then 4.
Yeah. So split up into the perfect square, which is 4 times 5x. Take root 4 times root 5x, and root 4 is 2, so we get 2 root 5x. Okay, so you're allowed to do that. And then what's this one? What do we do with the square root of x cubed?
X squared plus x times the root of x
So x root x, right? I think that's what you're saying, yeah. Okay, does everybody know how that came to be? So you split x cubed up into x squared times x. Right, here, my scratch, here's my scratch pad here, right? Root 20x is equal to root of 4 times 5x. Root 4 root 5x is 2 root 5x. Okay, that's that first one. Square root of x cubed is, I need a perfect square, which is x squared, so I just split it so it's 1 less than the power times the thing, the variable, so it's x squared root x, and the square root of x squared is x root x. So that's where the second part comes from. So if you're going to do that, just make sure that it's right. Okay, but if you're not going to do all the steps, just make sure that it's correct. Okay, and that's all over 2 root x, right? I can't forget about that. So what I can do now is split it up and write it like this. 2 root 5x over 2 root x plus 8x root x over 2 root x. So what I'm showing there is each part must be divided by 2 root x. So what's 2 root 5x divided by 2 root x? Just be root 5, right? 2 divided by 2, the 2's cancel, you just got a 1. Root 5x divided by root x. Okay, cross off the x's, right? Root x goes into root 5x, root 5 times. And what do we get here? Or x. So the answer is root 5 plus 4x. Question? Okay, nothing more on there. Multiplying binomials. How many products will we get when we multiply 2 binomials together? What's the magic word for multiplying 2 binomials? Starts with an F, ends with an oil. Foil. So we are going to get 4 products. So what's 3 root x times root x? What's the square root of x squared? So 3 root x times root x is 3 root x squared, but root x squared is just x, right? So when you see a radical multiplying itself, try not to think of it like when I say, what's root 7 times root 7? It's not a rhetorical question. What's root 7 times root 7? 1, 0. Yeah, you caught me off guard. I don't know. What's root 6 times root 6? Thank you. What's root 99 times root 99? 99. What's root x times root x? X. So 3 root x times root x is 3x. 3 root x times minus 1 is minus 3 root x. 5 times root x is 5 root x. And 5 times negative 1 gives me minus 5. So we get 3x plus 2 root x minus 5. Okay, so it collects into 3 terms. We have 2 like terms, right? The outer and inner. And we're done. How do you square a binomial? I do it the easy way, and then we'll do it the expanding it way. Okay? You do whatever you like. I square the first term, which is going to be 4w. I multiply the two terms together, giving me minus 12 root w, and I double it. So I get minus 24 root w, and I square the last term, and I get plus 36. Okay. That's one way to do it. Another way to do it, just write it down. When you square something, it means to multiply it by itself. So write it out as two binomials times each other and then use FOIL. Okay. So whatever works for you, right? There's lots of different strategies. It says determine, it just means you have to show your work. Okay, 2 times 2 is 4. What's root w times root w? W. Minus 12 root w. Minus, that's this, right? That's the outer, so we did the first. The inner, minus 6 times 2 root w is minus 12 root w. And negative 6 times negative 6 is positive 36. So 4w minus 24 root w's plus 36. Okay, so when you're doing the assignment, just look and say, what have I got here? It's a monomial times a binomial. I just multiply it into both terms. Two binomials, I have to use FOIL. Squaring a binomial, if I know the pattern, I can write the answer out, or I write it out as the product of two binomials and I use FOIL. And lastly, again, we've got two binomials, so we use FOIL. 8 root w. What's 2w times, sorry, what's 2 root w times minus root w? Minus 2w, right? Negative 6 times 4, minus 24, and minus 6 times negative root w, plus 6 root w. Squeeze that in. So I have 8 root w's plus 6 root w's, which is 14 root w's minus 2w minus 24. So the only difference here, see in this guy here, the roots were first, so I got the term that had no radicals in it or wasn't a constant first. And here, one root was first, one root is last, so when I did the outer, that's when I got the term that didn't have a root or, you know, just had the w in it, because I'm squaring the square root of w. So if we like, and so if it's multiple choice, you don't know what form the answer is going to be in, right? Does it have the w term first, then the root w term, and then the constant, or vice versa, right? So if you look and you say, I don't see my answer there, just ask yourself, okay, wait, is a variation of my answer there, right? So this is what I got, but this is what they were showing, and I need to track it, and I thought they're the same. Okay, so don't panic, it's right. A rectangle has a length of 4 times the cube root of x, sorry, the square root of x cubed, and a width of 5 root x. Determine expression for the area. So what might we want to do? Might want to draw a rectangle. And label the sides. Here's my length, here's my width. And then I'm doing area. What's the formula for the area of a rectangle? So area is length times width. You didn't necessarily have to draw it, right? Because it's a rectangle, you just write out area's length times width. They told us what the length was. So 4 square root x cubed, and the width, 5 root x. And what's the product of those two terms? You can do this in one line, you can do this in 2 lines. So it's 20 times the square root of x, or sorry, times the square root of what? X to the 4th. And what is the square root of x to the 4th? X squared. Now, beware, you might see a variation of this question, so don't think, oh, that's that question that I saw, right? Where I give you the area and the length and ask you for the width. Right? In which case, you just start off with the formula, and then you say, well, width is area over length, and then this becomes a division problem and not a multiplication problem. Okay? So it's very important to read the question, just not assume, oh yeah, I've seen this question before. And that's it.